Hi, welcome to my YouTube channel. This is C Chamba Jeko. All right, so in today's video, we'll try to look at a cubic function exam question. All right, so the question looks like this. So we first need to find the value of k. So how do we find the value of k? Very simple. If you can see on the table right here, you'll find that there is a table of values where we have x, okay, x and y. So for x we have -3 on top, and then y we have k. So we need to solve for k. For us to solve for k, we first get the given function, which is right here. This is a given function, the one I'm writing down here. Hopefully you guys are able to see nicely. So now this given function, we know that the value of x is -3, okay, where the value of y is k. So now we need to find the value of k. So put -3 here, okay. So now, because it's a negative number, you don't need to forget the brackets. You have to put it inside the brackets. If you don't put it inside the brackets, you might get your answer wrong. So remember to put it inside the brackets, okay? The -3, where x is, we're putting a -3, and solve. You get -27 right here, and here you get a 15 plus 3. So when you work out things, you find that the value of y will be equal to, right here we have a -27 plus 18. So this is 18. 15 plus 3, it's giving us 18. So of y is equal to -9. -27 plus 18, we're getting a -29. So meaning the value of k is equal to -9. So you now write it on your graph paper, okay? You need to indicate, you say, this is question what? Question 1. Okay, k is equal to -9. That's all. We go to the next question. So the next question right here reads, using a scale of 2 centimeters to represent 1 unit on the x-axis, -3 is less or equal to x, less or equal to 3, and 2 centimeters to represent 5 units on the y-axis for -10 is less or equal to y, less or equal to 20. Draw the graph of y is equal to x power 3 minus 5x plus 3. All right, so we know our scale right there, okay? The scale is very important. So we start with the x-axis. So for the x-axis, we will write, or we'll draw it right here, okay? This is our x-axis, and it's very important to know the scale. So this is our x-axis. So if my 0 is right here, my 1 will be here, my 2 right here, my 3 here, and my, yeah, up to 3, because the scale ends at 3. Here we have -1, -2, -3. Okay, so this scale is starting from -3 up to 3, where it says -3 is less or equal to x, or less or equal to 3. So this is how it's supposed to be. Forget about this part. And this is our x-axis. All right. Okay. So now, um, how did I know that I'm supposed to be counting or moving in ones? It's because they have said 2 centimeters to represent 1 unit. So this box is 2 centimeters. So from here to here is 2 centimeters. Here to here is 2 centimeters. Now you move in ones, okay? So we go now to the y-axis. So the y-axis must be like this, okay? So y-axis, we are moving in 5 because they said 5 units. So this is our 0, our 5 must be here. Next is 10 because we're moving in 5. So from 5 to 10, 10 to 15, 15 to what? To 20 right here. So this is our y-axis. Okay. Going down, still the same. We are ending at 10, negative 10. So this is negative 5, negative 10 right here. So this is how my Cartesian plane looks like, or x or y plane looks like. So now it's now the duty of plotting. So now to plot, let's check the table. Look at the table nicely. That's where we get the coordinates. And before we start plotting, it's very important you understand what each line mean here. So along the x 0 0.01, 0 0.01, 0 0.01, these are 0 0.01. So how did I know? So since there are 10 lines here, okay, from here to here there are 10 lines. So you say 1 divided by 10. Even here, if you want to know each line, what each line means, you will say 5 divide by 10. So what are we getting when we say 5 divided by 10? 0 0.5. So each line is 0 0.5. So this is 0 0.5, 0 0.5, these are 0 0.5. Such that two lines are making one. So the 2 is right here, the 3, the 4, the 5. You need to skip one line along the y-axis. X-axis is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, 1, 1.1, just like that. So this is very important. You need to know this. So starting now to graph, our first coordinate will be, our first point will be negative 3, comma 9, or comma negative 9. Remember, we found the value of k to be negative 9. So negative 3 is right here. If 10 is right here and we're skipping one line, negative 9 must be right here, because this is 5, 6, 7, 8, 9. Negative 9 is right here. So the point is over here. Next, we go to negative 2, comma 5. So negative 2 is right here. 5 is here, so the point will be right here. Next is negative 1, comma 7. Negative 1 is here, so this is 5, 6, we're skipping a line. 6, 7 is right here. It's here. Next is 0, comma 3. So this is 0, 1, 2, 3 right here. Let me do it nicely. 1, 2, and the 3 is over here. 3, yeah, is right here. So this is where the point is. You must make sure that you follow the points nicely. Next is negative, 1, comma negative 1. 1 is here, negative 1 is right here, because this is 0, negative 1 is right here. So this is where the point is. Next is 2, comma 1. 2, comma 1 is right here. Next is 3, comma 15. 3 is here, 15 is right here. This is 15 right here. So this is where our graph will pass. So we can now draw, make sure I do a very smooth graph like that. It's passing right here. And mind you, you're not supposed to use a pen, you're supposed to use a pencil. Okay? In case you make a mistake. So this is how my graph will look like that. So you see, this is why they encourage us to use a pencil. If you make a mistake like this, it's very easy to erase. Okay, so even right, this graph is y is equal to x power 3 minus 5x plus 3. You indicate. All right, so we're done with the graphing. We now go to the next question. So the next question right here, they are saying using your graph to solve the equation. Okay, now look at this. This is very important. They're saying using a graph to solve the equation. Now, how does the equation look like? So let me write it here so that we understand, we see what this thing is all about. So this is the equation. They have given us this equation right here. So they want us to solve this equation using the graph. Now look, do we have this graph? No, we don't have. The graph we have is this one. Look at the graph we have. It looks like this. This is a graph we have, okay? This one. So we can't solve this equation using this graph. We need now to make this graph look like this one. How do we make it look like this one? We put what has been removed from the graph. So here, what is it that has been removed? It's a 3. So we add a 3, this 3, to both sides. So even the other side here, we'll put a 3, like that. So now it looks like the graph we want to use to solve the equation. So meaning this will be like this. This is how it will look like. Good. 0 plus 3 is just a 3. Now, here we can solve using a graph. So what we're going to do now, we'll say y is equal to 3. Because here, on the function, we know that y is equal to x power 3 minus 5x plus 3. So now we'll say y is equal to what? To 3, right here. All this thing is the same as this, okay? So it's a y is equals to 3. We need to plot this, y is equals to 3. So how do we plot y is equals to 3? We know that y is equals to 3 will pass through this point. Y-axis 3 is right here. So the graph will look like this. Or the line will look like this. So we even indicate that this is the y is equals to 3. Now, once we do that, we start getting the solutions, okay? Mind you, this is question what? This is question 3a. So say question 3a, we need to indicate question 3a, number one solution here, it's right here. We follow the intersections. At which point is this graph meeting the line y is equals to 3? It's here and here, also here, okay? Here, and here. So this is where we'll get our solutions. So the first one will be x is equal to negative 2.12.2. So the solution, we get them along the x-axis. You go where the intersection is and then check what number is here straight with the point along the x-axis. It's negative 1, negative 2.1.2. This is negative 2.2. The next solution will be right here where it's meeting. What's the value of x here? It's a 0. The next will be right here. What is the value of x? The value of x here is 2.2. Okay, so these are the 3 solutions. Now remember, you can't get, it's not that much easy to get the same answers. So if you are the 10 of you, it's not it's possible, but it's not 100% possible to get the same answers. Somebody may get a negative 2.3 here or 2.1, they will still mark you. Here, if you get here, automatically it's supposed to be a 0 because that's where it's passing at 3. So here it's supposed to be a 0. But here you may get a 2.3 or 2.1. They will still mark you. So that's it. This is what you need to know. All right. We go to the next question. They are saying, estimate the area bounded by the curve y is equals to 3 and x is equals to negative 2. So y is equals to 3. This is y is equals to 3. It has been graphed already. And x is equals to, sorry, y is equals to 3. Sorry, did I say? Yeah, it's right here. And x is equals to negative 2. X is equals to negative 2 is right here. So this is what you do. You graph your x is equals to negative 2 right there. So the region they want us to find the area of is right here. This is the region, okay? This is the region right here. You see the region? This is the region. So now how do we find the area bounded by this region here, okay? And how did I know that this is the region they are talking about? It's because it has been bounded by this and then makes a turn and this graph. So right here. So we'll say, let me put it here, 3b. This is what we'll do. We'll say, okay, What is the area of a box, a normal box right here? The area of a normal box is, this is a rectangle, and we'll say area of a rectangle is equal to AO times B. That's the area, okay? So now, we'll come and say our our length here is a 1, okay? So put 1. And our B breadth from here to here is what? It's a 5. So 1 times 5. And the answer there is 5 square unit. 5 square units, okay? Or 5 square units square. This is our area. So it's the area of a finished box. You see this box. Any box here, it has got this area. Now look at this bounded region. How many boxes or full boxes do we have? We don't have any. We have this one, the chopped one. This one is also chopped, and this one is chopped as well as this one. They are not finished boxes. So what we do, we'll count how many boxes, how many unfinished boxes do we have. We have 1, 2, 3, 4. There are 4 of them. Okay. So now we'll say, since they are not finished, if they were finished, these boxes were finished, we would have just said 4 times 5. And that's our answer. Now, since they have been cut, they have been chopped, so we'll divide by 2. Always divide by 2 if they are chopped, okay? And then you get 2. So now this 2 multiplied by the total area, I mean the area of one finished or one finished box. So to show our work, we'll do this. We'll say area over a finished box is that. So we'll say 1 times 5, like we did, and we'll find that our answer will be equal to 5, okay? Square units, okay? So this is the area of a finished box. So now we'll come and say, how many boxes do we have there? Here, how many boxes do we have? There are 3. There are 4. 1, 2, 3, 4. So there are 4 boxes, and these boxes, they are chopped. So we divide by 2, and we'll get a 2. So now these 2, we'll say a 2 multiplied by a 5, which is the area of a finished box. We'll get a what? We'll get a 10. So 10 square units. Okay? So this is our solution. We now go to question B, okay? So all this question is question 12A. Now question 12B. So this is 12B right here. So for 12B, we'll say, because the question reads, let me read it for you. Find the equation of the tangent to the curve. So the curve is right here. This is the curve they are talking about. Okay? At the point where x is equal to -1. Okay? So we need to find the equation of the tangent at the point where x is equal to -1. So at which point is x is equal to -1? Here, right here, -1. So meaning y at the point where x is equal to -1, y will be equal to what? To 7. Okay? So we have -1, 7 there. This is a point. They want us to find the gradient. So what are we going to do there? This is what we are going to do. We'll get the given equation. Okay, we get the given equation right here. This is the given equation. So now we'll find dy dx of this function. So what is the dy dx? This is calculus. So we're going to use what we call power rule. So this is how it will look like. Okay, this is how it will look like. And like this, I will explain. Let me just find here, and then I'll explain. Okay, so I'm using power rule here, which will just be like this. Okay, so this is the the first derivative. Okay, I've differentiated. So dy dx is this one. So power rule, the way it works, you get the power which is up here, okay? Since there are brackets here, you get the power, multiply it by the number that is in front here. So in this case, there is a 1. 1 times 3, it's a 3. And then bring back what is inside the brackets. After bringing back what is inside the brackets, differentiate or find the derivative um, of what is inside, okay, with respect to x. So in this case, the derivative of a constant is a 0. The derivative of 2x is a 2. So once you get that, this and this can be multiplied. So you just say 2 times 3 is a 6. So and to the power here, remember the way we do when finding the when differentiating or finding the derivative, we subtract a 1. So I said 3 minus a 1. I ended up with a 2. So that's what I have. So now, according to the question, they said the x value is negative what? Negative 1. So now, for us to find the derivative, I mean the gradient, sorry, to find the gradient, we'll let x be equal to negative 1. This is the negative 1 they have just given us. So we'll put it right here, negative 1, where x is, and then solve. So what are we getting? We're getting a 6 here, negative 2 plus a 3 power 2. And when we work out, we get a 6 here, a 1 power 2, which is equal to 6. So our gradient is equal to 6. Okay? So since you have to show your work, you have to show your work here. So all the steps must be shown right here, what you are doing. So I'll say uh, dy dx is equal to 6, okay, 2x plus 3 power 2. This is what I did right here. If you saw what I did, this is my dy dx. Then I let x is equal to negative 1. So now x is equals to negative 1. I will say my m now. My m is 6, okay? And there I'll put a negative 1 where x is here, plus a 3 and the power 2. And when I work out everything, I'll get my value, or the value of m, or the gradient, to be equal to 6. So we have found that gradient. Now we use the formula for finding equation of a straight line, which is y is equal to mx plus c. So at y, I will put a 7, this 7 right here. And at m, I'll put a 6. My gradient here is a 6. At x, I'll put a negative 1 plus c. When I work out things, I'll get a negative 6 plus c. We group the like terms. We find that our c will be equal to 13. Yeah, it's 13, right? Yeah, it's 13. So my c will be equal to 13. So that's a procedure. This is a procedure. So I'll write it here, the formula, to show, so that the marker, I can convince the person who will be marking my work if it's an exam. Okay? Marking my work, that, oh, I knew what I was doing. So here 7 is equal to 6 negative 1 plus c. So my c, when I work out things, will be equal to 13. This is 13, according to what we did here. Our c is 13. So y will be equal to 6. I'll put a 6 here because my gradient is a 6. X plus 13. This is our answer. Thank you so much for watching. Don't forget to subscribe to my YouTube channel, and to those who would like to join our online tuitions. Okay, we help out quite a number of people. So if you are facing challenges in mathematics, you can join our online tuitions through the number 0969175701. So this is a number you can text us on WhatsApp. And You can also follow me on my Facebook page, just Jacob Sichamba Online Math. So this is my Facebook page. The same name on YouTube, the same name on my Facebook page.